Welcome back to Stay Home, Stay Safe chemistry class with Mr. Picard. And today I'm going to be behind the camera, not in front of it, simply because I want to show you some things up close. And I'm filming alone. It's easier than cutting and editing everything. So I would like you to get out your periodic table of elements. You can use the table, ideally use the table I posted as a PDF that you print out, or find another table that looks something like this one, ideally in color and ideally with the family and group names. And let's take a look at this table for a moment. It is actually different than the one I posted. This is missing something, and it's simply missing the numbers that we use to refer to the groups or columns. So the one, if you printed out the one I gave you, there's a 1 and a 2, and it goes 3, 4, 5, 6, 7, 8, and actually it starts back up here at 13, 14, 15, 16, at 17, and 18. And then there's some other numbers on the table I gave you that are Roman numerals, and we're going to talk about what those Roman numerals mean at the top of each of these columns or groups next time, or the time video after. I asked you in the previous lesson to look into this group, because this first group 1 has a special name and it has unique properties. And if you use the key here, you can, I don't think you can see it in the video, but on your own table, you can see if the rose-colored most of the elements on this column are kind of rose-colored, and it's the alkali metals. And let's look at a typical card. And we'll look at sodium. And this, I think you can see if I hold it carefully. Let's see. Can you read that? And let's look at what it has to say about it. First of all, it's got a chemical symbol of Na, comes from the Latin name for sodium. Among other things, we find it's a soft, silvery solid metal. It reacts vigorously with water, and it also reacts with chlorine to form NaCl, sodium chloride. And we say chloride, but it's a combination of sodium and chlorine. And we'll talk more another time. We'll learn about why it's called a chloride, but it's just a simple combination. And so this is what a typical alkali metal looks like. An untypical member of this group is way up at the top here, hydrogen in blue. And it's a bit interesting that it's in this group. It shares properties. In other words, it has ways of reacting with other elements and behaving that puts it in this group. Then it has other, and structures even in the nature of the atom. And it's this very, very simple atom. It's a single proton. It's colorless, it's odorless, and it's a non-metal. It's the only element in group 1 that is not an alkali metal. It's usually found, it's often found in combination with chlorine as HCl gas. And it doesn't react with water, but it explodes in air if it has a spark, if it has an ignition. So this is hydrogen, sort of the exception within this first group that you identified in the last lesson as alkali metals. So we're going to come back to hydrogen a different day. But today I want to show you actual samples I have of these metals, and we're going to see if we can react some. And so let me set that up quickly. And I have some lithium. And lithium reacts very quickly with any kind of water or even moisture in the air. So I'm going to open this up, and I think you'll be able to see inside that it's sort of in some liquid. Can you see that liquid in there? And that liquid is not water. It's in fact mineral oil that is hydrophobic. It keeps water from touching any of this lithium so that it doesn't react. Let's take a piece out and take a closer look at it. So there's a piece of lithium. I'm going to close up the bottle. keep things safe here and move it to the side. And one thing you might notice about it is it's not perfectly silvery. It's got this black color to it, and that's because it has reacted a little bit with moisture in the air, and we get that outer coating. But let's cut into it and see what it looks like, sort of fresh, so to speak, before. And so I'll hold it with the tweezer, and let's cut it. Actually cuts pretty easy. It's about like a piece of coffee, and I think if you look in that, you can see that it's actually quite shiny and definitely metallic. It's a metal. It's also very lightweight. It's not weighing very much. In fact, it's so lightweight, it's less dense than water. That's what I meant by weight, actually, density, and it will float. And you can already see that it's darkening a little bit, but that's what lithium looks like, and it is the first alkali metal in group 1. I'm going to put that back into storage here and into the mineral oil to keep it from oxidizing anymore. I've made a video previously where I drop this in water to see how vigorously or not it will react compared to the other alkali metals. Let's take a look at the other metal that alkali metal that we'll be investigating, and we're going to investigate its reactivity. Let's open that up, and let's take a look at that. And you can see, I think, that got some big chunks of sodium, which has the symbol Na. And it is a little heavier. It's not floating in the mineral oil. And I'm going to take out a big chunk of that. I'm putting it down in a piece of paper towel so that it soaks up a little bit of the mineral oil. And it's a little bit discolored on the outside, but let's cut into it and see what it looks like, you know, sort of fresh, so to speak. So I'm putting this aside, and I'm going to cut this in half, and we'll take a look at this. Wow, this is even easier to cut, almost as soft as butter, and very, very shiny inside. I think you can see how shiny this sodium is. And I bet if we leave it in the air, you can almost start to see it change color as it does react with a little bit of moisture on this May 10th day. So it's a little bit humid. And that is what sodium looks like, okay? And I'm going to put that back in safe storage. So I'm going to put up 2 videos that I made previously where I take a sample of sodium and a sample of lithium metals and simply drop them into water. And we'll see if they react the way the periodic table predicts. And also you should refer to your cards. Sodium, lithium, sodium were just below hydrogen in group 1, and below sodium was potassium, and below potassium was rubidium. These squares are similar to the ones that are on the periodic table. All right, so take a look at the other videos. I'm actually going to post 3 short videos that demonstrate investigating the properties of the alkali metal group, in particular how they react with water.